Watch how these abstract geometric shapes snap together perfectly to form this solid, polished button. Building a high-impact user interface element from scratch is one of the most satisfying parts of development. That satisfaction quickly turns into a liability if you duplicate code across 20 different screens. Copying and pasting identical UI blocks is a common workflow error that bloats the project. The problem reveals itself the moment a client requests a design change. They want the primary button color updated from blue to green, everywhere in the app. Take a look at this code editor. You are now scrolling through a bloated column widget, hunting for every isolated instance of that button to manually edit the color hex code. Hard-coding repetitive UI elements creates fragile applications that break under routine updates. Reusable widgets provide the single point of control needed for professional development. To solve this, we create a new class named CustomButton that extends StatelessWidget. This serves as our single source of truth for the entire application. As this schematic shows, your new class functions as a universal blueprint. Defining the structure once allows the system to stamp out identical copies across every screen. For this button to be flexible, 3 specific properties must remain dynamic: the text label, the color value, and the on-pressed tap action. We declare these 3 variables at the top of our class using the final keyword. Marking these as final locks the values in place the moment the button is instantiated. This prevents the widget's internal state from changing unexpectedly during the user session. The tap action uses the void callback type. This lets you pass a function into the widget just like a standard string. Abstracting these properties into a dedicated class creates a modular system where a single change to the template propagates to every button instance automatically. The class constructor acts as the entry contract for this widget. It dictates exactly what data must be provided before the button can be rendered. Dart's sound null safety ensures that non-nullable variables cannot be left empty. This prevents common runtime errors before the code even executes. In this code block, we use the required keyword for the text and tap action. This forces the developer to provide that data. For optional data, we provide a fallback default. If unspecified, the widget defaults to colors.blue. Strict constructor rules and default values eliminate unpredictable null dereference errors. This makes the widget reliable for every member of the development team. Now we can see the scalability in action. We have a login screen and a payment screen, both currently using redundant code blocks. On the login screen, we select and delete the massive block of legacy spaghetti code. We replace those dozens of lines by calling our CustomButton widget once. We satisfy the contract by passing in the login string and its specific navigation logic. We repeat the cleanup on the payment screen, stripping out the old duplicated layout. We instantiate the custom button again, but this time we override the default color with a custom red value for the payment confirmation. When the client requests a global change to green, we update the default color in the core CustomButton class on the left. As the code changes, the mobile emulator on the right updates instantly, propagating across every screen simultaneously. Scalability means that updating the application remains a low-effort task. Whether you have 2 screens or 200, a global change requires editing exactly 1 line of code. Architects build systems that scale efficiently. Prioritizing modularity over immediate layout results in a maintainable project. When small modular components link together, they form an organized network that remains stable as the application grows. For more advanced software engineering tactics and Flutter architecture secrets, subscribe to the channel. Mastering code reusability is the definitive dividing line between an amateur programmer and a professional software engineer. Keep building, and we'll see you in the next one.